Hello, so let us look at few more problems in today's class. So we look at solution of ordinary differential equation. So the first equation is y dash plus y equal to 3 e raised to 2x, y at 0 is equal to 0. So let us take Laplace transform on both sides. So we will get, so this will be p into L of yt, so L of y minus y of 0, so that will be L of y dash plus L of y varum, so that will be equal to L of 3 raised to 2x. So you will get p L of y plus, so y at 0 is 0, so p L of y plus L of y, that will be equal to 3 by s minus 2 varum. So therefore L of y will be equal to 3 by s minus 2 into p minus 2 into p plus 1 varum. So now let us reduce this into partial fraction. So 3 by p minus 2 into p plus 1. So let us put it in the form a by p minus 2 plus b by p plus 1. So 3 will be equal to a into p plus 1 plus b into p minus 2. So put p equal to 2. So that will give a p2 വരുമ്പോൾ a യുടെ value 1 വരും. And അതുപോലെ p equal to 3 p equal to minus 1 എടുക്കുമ്പോൾ we will get minus 3 here. So b is going to be equal to minus 1. So therefore L of y will be 1 by p minus 2 minus 1 by p plus 1. So therefore our solution is y of t equal to, y of x equal to, so this will be the 1 by p minus 2 വരുന്നത് നമ്മൾ e raised to 2x എടുക്കുമ്പോഴാണ് p raised to 2x minus e raised to minus x. So this will be the value of y of x. And next we have y double dash minus 4y dash plus 4y equal to 0. So y at 0 equal to 0 and y dash of 0 is equal to 3. So taking Laplace transform, so we will get p square into L of y minus p into y of 0 varum, that is 0 varum, minus y dash of 0, so minus 3 minus 4 p into L of y minus 0, then 4 L of y equal to 0. So that gives p square minus 4p plus 4 L of y will be equal to 3. So therefore L of y is going to be equal to 3 by p. So this is p minus 2 whole square. So therefore y will be equal to L inverse of 3 by p minus 2 whole square. Now 1 by p square, L inverse of 1 by p square is going to be equal to x. So L inverse of e raised to 2x into x will be 1 by so L of e raised to 2x into x will be 1 by p minus 2 whole square. So L inverse எடுக்கும்போது you will get 3x e raised to 2x. So that will be the required value of y. Now let us look at the next set of properties of Laplace transform, which is on derivatives and integrals of Laplace transform. So we consider the integral f of p. So f of p is given by integral, that is the integral of the Laplace transform. So it is e raised to minus px f of x dx. And now f dash of p is given by, so that is d by dx of integral 0 to, d by dt of integral 0 to infinity e raised to minus px f of x dx. So that will be equal to integral 0 to infinity d by dp of e raised to minus px f of x dx varum. So that is integral 0 to infinity. So we will get minus x e raised to minus px f of x dx. So now this integral will be actually L of Laplace transform of minus x into f of x. So therefore L of x into f of x is going to be equal to minus f dash of p. Okay. So therefore when you take the derivative of your Laplace transform, that f of p, small f in a Laplace transform anengil, when you take minus f dash of p, that will be Laplace transform of x into f of x. So if you have a function in the form x into f of x, f of x in a Laplace transform kandupidikka, then that is f of p kandupidikka, then minus f dash of p is going to be the Laplace transform of x into f of x. Now similarly, when you differentiate it twice, so you are going to get L of x square f of x will be, so you will get minus 1 whole square f double dash of p. So which is f double dash of p. അതുപോലെ L of x cube f of x എടുക്കുമ്പോൾ that will be minus 1 whole cube f3 of p. So that is minus third derivative of f of p. So in general, L of x raised to n f of x will be minus 1 whole raised to n fn of p. So this is the property on the derivatives of Laplace transform. Now let us look at an example. So find Laplace transform of x sin ax. So we have Laplace transform of sin ax as a by p square plus a square. So therefore L of x sin ax will be equal to minus of d by dp of a by p square plus a square. So that will be equal to minus of, so using quotient rule you will get p square plus a square whole square, then 0 minus a into 2p varum. So that will be 2ap by p square plus a square whole square. So this is the Laplace transform of the function x sin a. Now the next problem is calculate the Laplace transform of root x. So again we will use the previous result we have seen. So that means we will express it in the form L of x into f of x. So L of root x can be, so that is L of x raised to 1 by 2. So this can be put in the form minus L of minus x into x raised to minus 1 by 2. So now we know that minus L of minus x into f of x is going to be equal to f dash of p. So this will be equal to minus d by dp of L of x raised to minus 1 by 2. Okay. Now we need to find what is the Laplace transform of x raised to minus 2. So let us look at what is Laplace transform of x raised to minus 2. So by definition, that is integral 0 to infinity e raised to minus px x raised to minus 1 by 2 dx. And now let us put px equal to t. So therefore p dx will be equal to dt. X varies from 0 to infinity, so therefore t will also vary from 0 to infinity. So that is integral 0 to infinity e raised to minus t. X എന്ന് പറയുന്നത് t by p വരും. So this will become t by p whole power minus 1 by 2. Now dx will be dt by p. So we will get integral 0 to infinity e raised to minus t raised to minus 1 by 2 by p dt varum. Okay. So therefore we are going to get, so this is p raised to 1 by 2 varum. Okay. So that will give us p raised to minus 1 by 2 integral 0 to infinity. So you are going to get e raised to minus t raised to minus 1 by 2. E raised to minus t raised to minus 1 by 2 dt. And now we will use one more change of variable. So put t equal to s square. So when you put t equal to s square, so you will get dt equal to 2s ds, and again s will vary from 0 to infinity. So we are going to get p raised to minus 1 by 2 integral 0 to t e raised to minus t, then s square s raised to minus 1 varum, and dt will be 2s ds. Okay, so that is minus, sorry, this is zero to infinity. So this is e raised to minus s square, 2 veli varum, and we have s into s raised to minus 1, but this will be the integral. So we will get integral 0 to infinity e raised to minus s square ds. And now we need to evaluate this integral 0 to infinity e raised to minus s square ds. Now let us take I equal to integral 0 to infinity e raised to minus s square ds, and now I into I will be equal to integral 0 to infinity e raised to minus s square ds into integral 0 to infinity e raised to minus s square ds. And now okay, so instead of s I will use a different parameter for the second integral. So that is e raised to minus u square du. So this will be I into I. Now let us combine these two integrals. So you will get integral 0 to infinity e raised to minus s square e raised to minus u square ds du.